Alright, the next two functions are just subfunctions called by the init function here, the set LED and the init LED pins. Let's move on to the next set hook, which is the 100 millisecond timer loop. In node code and Snappy node, this code is run every 100 milliseconds. And what we do is we go ahead and take a poll count. So we count the number of times that we've been in this function. And then that allows us to do different functions in different time intervals inside of this loop. So what we're going to see as we scroll down the code here, we're going to see the first thing we're going to do is if we don't have a CIK number, every 20 seconds we're going to go ahead and send the Exosite provision command out to the E10. Again, we send it with the vendor ID, we send it with the model ID, and then the MAC address of this node is also sent with that remote procedure call function. So we're going to try and get our CIK number every 20 seconds if we don't have one. We're also, if we don't have the gateway address, we're also going to try and pair. So every 20 seconds we're going to try to get our CIK number, and if we don't have our gateway, we're going to try to pair with a gateway just to see if we can get a gateway to respond. We have a little blink of an LED here every couple seconds, and then we have the function here. Once we do have a CIK number, let's go ahead and assume that we might need to get a new CIK number. And if we do, this is called a reprovisioning. We're not going to check for reprovisioning as often because it doesn't happen that often. So every 5 minutes, we're going to go ahead and send off an Exosite provision, again with the vendor ID and the model ID, to go ahead and see if there's a CIK number, new CIK number, if we've been reprovisioned. And we're going to do that every 5 minutes. This doesn't happen as often. Now we get into the workhorse function inside of this loop that we're running on the node code. So if we have a CIK number and we have a gateway address, now we're actually going to start sending data to the Exosite platform, useful data from our system. And the first thing we're going to do is send this ping. So we're going to do an Exosite write to the gateway address that we know for the E10. Again, we're going to give it the CIK number, which identifies this node uniquely in the Exosite system. We're going to send the alias ping, and we're going to send the value of ping. And ping is going to update every 2 minutes. It's going to be a counter that continues to update inside the Exosite system. So ping is our first function. The next one down the list, we're going to go ahead and calculate the quality of the link, so the link quality. And we're going to go ahead and send that. We're going to calculate it here and then send it to the Exosite platform. Again, using Exosite write with the CIK signal as the alias, and then as the signal, whatever the value is we get on the signal as an integer. So we're going to send that to the platform every 1 minute. We're going to send the photo and temp sensor values every 30 seconds. And for this one, what we've done here is we go ahead and get the photo value and the temp value through these read functions. But then we're going to take the data and we're going to actually build a packet. So we're going to build a packet, a string of analog temperature value, comma photo value. And this is going to allow us to put together a packet that we're then going to break apart in a script inside the Exosite platform. So we're going to go ahead and, again, Exosite write with the CIK number with the packet as the alias, and then give it the packet string that we've created here. Again, inside the Exosite platform, we're going to break that string apart inside of a script function and put it into individual data sources. Now let's look at reads from the Exosite platform. So what we're going to do is every 2 seconds we're going to go ahead and read the green LED and the red LED data sources inside of the platform. And how this is accomplished is we do an RPC call to our gateway address. We execute a command function on the E10 called the Exosite read. We pass the parameters of a CIK number and the parameter of the alias, which is LED green. Because we're doing a remote procedure call, again, the MAC address of this node is also being transferred to the E10. So the E10 is going to go ahead and execute this Exosite read function. It's going to go up to the Exosite platform, do a read command with the CIK and the alias, and when it gets that back, it's going to execute a function later on here, which is called the Exosite response. And it's going to call the Exosite response function of this node from the E10, also using a remote procedure call. What happens here, you can see that there's a couple of if statements here. We don't want to keep reading this value over and over again, because our response time from the E10 to call that Exosite response function, we don't want to keep calling this over and over again and have those response functions kind of add up. So what we do is we set this flag, the waiting green LED flag. It's set to false when we start up, and then in this side of this function we go ahead and we set it to true. So once this function executes one time, we'll set that function to true, and therefore this will not go in here, not come in this if statement. It'll go to this else statement, and the else statement just adds 1 to it. So if we go through this 5 times, or about 15 seconds, we'll end up going back in here and executing another read for the green LED. So once we execute a read, we want to wait about 15 or 20 seconds, and we use this timeout and the green LED wait to do that. We do the exact same thing for the red LED. Again, it's a remote procedure call to the gateway address. Exosite read is the function, and then the CIK number and the LED red. And if we come down further, you'll see that the response to that packet is in this function right here, called the Exosite response. The response function called by the E10 calls this function on the node, provides the net ID, which is the MAC address for this particular node, the data port, which is the alias from the Exosite platform, and the value, which is the value that it read and got back from the Exosite platform. And then what we do is we do a function based on if the data port returns the LED green, we go ahead and set the waiting to false again. And then if that value is 1, we set the pin to true, and if the value is 0, we go ahead and set that pin to false. And we do the same thing for the LED red. So depending on what data values you would read, what aliases and what values of those aliases, you would go ahead and execute whatever functions you wanted in here to compare, to check the alias, and then decide what you want to do depending on what the value of that alias is in the val function. Let me show you one last function in this code. We have another set hook in here called the hook gpin, which basically, if you monitor a pin on the node and that pin is triggered, it will execute this function. This is very useful if you want to set up several pins to be monitored and then do certain functions if those pins change status. In this particular one, we're just looking at GPIO 5, which is the push button on the eval board itself. And we set up earlier inside of the setup function or startup function, we set up pin number GPIO 5 to be an input, and we set it up to monitor that pin. So if something changes on that pin, it's going to go ahead and call this hook gpin function. And what we're going to do is, if that is, and we see that it is set, we're going to go ahead and execute a Exosite write on the E10. We're going to give it the CIK number of this node. We're going to give it the alias of button, and then we're going to give it a value of 1. And this is very useful if you want to monitor a system with your node talking to an E10, but you don't want to continuously monitor those signals inside of a loop. You can go ahead and set it up as a monitor pin and then execute this function when you need to. That concludes our walkthrough of the Synapse node code running on these Aero M2M kits from Synapse and Exosite. If you want more information about the kits themselves, you can go to synapse-wireless.com /Aero M2M kit. And you'll get this page here, which shows you the different kits. There's a 900 megahertz kit, a 2.4 gigahertz kit, and then a kit that allows you to serially replace an RS-45 connection. And you can order any of those kits directly from the website here. And the website at Exosite to go ahead and log in and create an account is arrowm2mkits.exosite.com. You can sign up for an account and then log in and see your data live.